In remote Siberia, the ground is detonating without warning, creating craters large enough to swallow buildings and releasing methane that could accelerate climate change beyond predictions. These mysterious explosions are occurring across the Yamal Peninsula, where the frozen ground is giving way to forces that have been locked away for millennia. The explosion phenomenon begins when warming temperatures the ancient permafrost, releasing methane gas that has been trapped in ice formations called hydrates. As pressure builds beneath the frozen surface, the ground literally blows open, creating craters up to 100 feet deep and 130 feet wide. The force is so powerful that it scatters debris hundreds of feet from the epicenter. Permafrost science reveals that this frozen ground contains twice as much carbon as currently exists in Earth's atmosphere. For thousands of years, this carbon has been preserved in a deep freeze, but rising Arctic temperatures, increasing 3 times faster than the global average, are now unlocking this ancient reservoir. Methane's warming power makes it a climate threat of extraordinary proportions. While carbon dioxide receives most attention, methane is 80 times more potent than CO2 over a 20-year period. When released from permafrost, it creates a feedback loop. Warming releases methane, which causes more warming, releasing more methane. The scale of the threat is almost incomprehensible. Scientists estimate that Arctic permafrost contains 1,400 billion metric tons of carbon, more than humanity has emitted since the Industrial Revolution. As these deposits thaw, they could release enough methane to raise global temperatures by an additional 0.5 degrees Celsius by 2100. Scientific expeditions to these craters are dangerous missions into one of Earth's most remote regions. Researchers must navigate unstable ground, extreme weather, and the constant risk of new explosions. Their work involves measuring gas concentrations, studying crater formation, and installing monitoring equipment to track changes over time. Current climate models significantly underestimate the permafrost feedback loop. Many projections don't fully account for abrupt thaw processes like these explosions, which can release methane much faster than gradual thawing. This means our current climate predictions may be too optimistic about how much warming we'll actually experience. The global implications extend far beyond Siberia's frozen landscapes. Increased methane emissions could accelerate sea level rise, intensify extreme weather events, and push climate systems past irreversible tipping points. What happens in the Arctic doesn't stay in the Arctic, it affects weather patterns and climate stability worldwide. Potential solutions range from immediate emissions reductions to experimental geoengineering approaches. Some researchers propose capturing methane at source points, while others investigate methods to refreeze permafrost. However, most scientists agree that the only sure way to slow this process is rapid reduction of global greenhouse gas emissions. Siberia's exploding craters represent a climate feedback loop that could fundamentally alter our planet's future, demonstrating how quickly nature can respond to human-caused warming. These geological events serve as a stark warning that climate change isn't just about gradual temperature increases, it's about triggering natural processes that can rapidly accelerate beyond human control.